All right. All right. All right. I say that all the time when I start the video, so I felt like saying it 3 times. We're going to close this. I don't care. We're going to leave this one open. We're going to close Shadowrun. Variables grew from the concept of registers. Registers is a hardware provided variable. That's a definition we're going to stick with. Registers with a purpose, general purpose registers. We started to get into that, and then we sort of trailed off into some crazy place. So we're going to try and take a somewhat. Do I have new updates? Are you kidding me? I hate Windows. Go back into Python. We are going to try to demonstrate in a somewhat realistic or understandable way what an opcode is in a general way. X equals 5. So what just happened there? You want to go way down to the level of the hardware, which is where what we are kind of starting to get into as far as cheat engine and things like that. What just happened was we are glazing over so many of the details here. I cannot even possibly stress that enough, but we're going to talk about it in generic ways. X equals 5. What just happened? Well, an assembly statement was executed such that move x5. So that the value of 5 was moved into the variable x. We have no idea what the variable x is, but this is sort of the equivalent assembly statement. If I was to hit enter and execute this, Python would complain. It has no idea what we're talking about. It doesn't know we're doing some strange video series. So bring up our trusty window here. If we were to say x minus 5, it's fine. X was equal to 5, x is minus 5. Python says, yep, I can do that calculation. The result of that operation or that calculation is 0. So what just happened? The processor executed or was fed an opcode of sub, and it was given x and then 5. Now there's some subtlety here because the variable x is that we have up here is not referenced in assembly by the actual name x. In reality, what's going on here is that the value of the variable x, which we know is 5 because we're the ones who assigned it, and Python knows it's 5 and the computer knows it's 5. This value of x, this is a terrible actual name. So let's restart this here. Or we're not even going to restart it. We're just going to delete it. Say hit enter a couple times and say var. I don't even want to do that. We'll say v equals 10, and then we'll say v. We'll just ask Python, what's v? V is 10. What is v plus 5? It is 15. What is v minus 5? It is 15. Or I'm sorry, it's negative. Well, we actually typed it wrong, so it's negative 5. But so, what is v plus 5? What happened here is that the processor was fed an opcode by Python under the hood that basically said add this. So it said take the value of v, which is 10, add 5 onto it, and then there is a misnomer here because as we talked about, opcodes or just operations in assembly in general will store the result in the first parameter or the destination parameter, as the case may be, and that is for the purpose of illustrating this sort of concepts, how it relates from a general level to a lower level and opcodes and whatnot. We are glazing over this detail, but rest assured that if you followed along with the previous videos, not the last video because that was kind of a mess, But certainly with the ones before that, where we talked about registers and whatnot, it should be clear that we are glazing over the detail of that the value is actually assigned to v. So we are just sort of dismissing the fact that this is not assigned to v in Python. I mean, yeah, that's what we're going to say. So we're feeding this to, and we'll get over it. We'll cover this in a minute, but there's an opcode that's fed to the processor. It's given some location in memory. In this case, it's the variable v, and then it's given some second parameter, which is 5. It takes 5, it adds it on that to that parameter, and then Python somehow magically gets back a value of 15. If we make it so that v is, or subtract 15 from v, it does the same thing. It says, well, there's v, and we want to subtract a value from it. What we're really doing is we're adding a negative value onto it. So you're adding negative 15 onto v. What do you get? You get negative 5. V is actually still 10 because, again, and there's all sorts of black magic that goes on that's preventing the variable name v from being reassigned. That's not important for our purposes here, but this sort of illustrates in a somewhat clearer way, certainly relative to the previous video, that what is the relation between basic arithmetic operations in any programming language relative to how they are executed in assembly. So now, I mean, sort of having this, sort of one-to-one, it's not a one-to-one mapping, but having this general mapping between these operations and how it shows up as assembly and cheat engine, you can sort of go back here a little bit and maybe bring this up and go to memory view and scroll down a little bit, see if we can find something interesting. So we got a whole lot of compares, we got jumps, we got pops, we got returns. Do we have any adds, any moves, something like that? So we talked a little bit about the move. What is the move? The move is essentially sort of an assignment is the equivalent of an assignment statement in a higher level language. So, what are we doing with this move statement right here? What we're doing is we're taking the value of EAX and we're assigning it to the memory location of EBP minus 1C. Whatever that memory location of EBP is, we're subtracting 1C from it, and we're taking the value of EAX and we're stuffing it in that memory location. So again, the movement is, and then obviously from here on out, EBP minus 1C, that's going to be whatever EAX currently is. So this is essentially this is the equivalent of an assignment statement. That's sort of a general way to think about it. When you see a move statement, you just think assignment is the way to sort of deal with that. See if we can maybe get into some add or sub. Let's see what we got. Let's scroll down a little. Here we got an add statement here. We're adding 0C onto ESP. Let me think about that for a second. We got 10, 11, 12. 0C is 12 in decimal. And Cheat Engine's giving you a little hint over here. You could double click, type in some crap if you wanted to. There's some more crap. But we're going to change that back to 12. Yep. So what's going on here? Well, essentially, again, it's opcodes and it's assembly and it's bit patterns, and on a lower level, there's all kinds of crazy nonsense going on here as far as how is the processor determining what to do. But for a general introduction, a way to think about it is just the same way that you think about a higher level operation. What's going on here? Well, you're taking 0C in hexadecimal. The first thing you're going to do to sort of understand this on a somewhat more intrinsic human level is you're going to take 0C, you're going to convert it to decimal. Just to be crazy about it, you could just go to hex, you could hit C, and then click decimal. What do you get? You get 12. So we're not crazy. Taking 12, you're adding it on to whatever the value in ESP is, and then that value is getting stored in ESP, and that's it. So again, the add opcode is equivalent to the add operation in any higher level situation. So when you think about it in those context or in that context, it is not crazy complicated, but when you just bring up the memory viewer and you start screwing around with values and thinking about, well, what's a push, what's a call, what's, I don't know, what's a return, and what's this little thing down here mean, and all the arrows and stuff like that. I mean, it's incredibly overwhelming. But so far, just on a general level, we've covered sort of that move is equivalent to assignment, add is obviously equivalent to add. See if we can find a sub. And yeah, we're gonna beat that horse to death. We got neg. I don't really care about that. We got SBB. I'm sure that's close, but I know there's a sub. Really? Come on. There we go. All right. So we have a sub operation here. What's going on? Well, it's taken the value or the hexadecimal value of 08, which is in this case it's under 9, so it's equivalent to decimal. 08, subtracting that from whatever the value of ESP is, and it's storing that value in ESP. So again, it's equivalent to just a general subtraction operation. And this sort of pattern is it follows for the basic arithmetic. You have div operations. Let's see if we can maybe find a div. Those are slightly more rare. But a div opcode would essentially be just dividing in basic arithmetic. I want to say there's an MUL or a mult, something like that. We can go up to Cheat Engine and ask it for help. Let's see what we got. Tutorials. That there was something up here that had to do with opcodes. We got sub. We got sub. He talks about move. Yeah, we're just looking for the basic list of generic opcodes. Hey, this is what we want. So we got, no, this is not what we want. This doesn't even go over it. It's very frustrating. Alright, there we go. Move, move, more move, more move, even more move. Add sub, MUL, and div. There you go. So you have mult, MUL, which I call mul, and you have div. Obviously, they're multiply and divide. So if you found these kind of if you were screwing around with, messing around with assembly or something in the program, and you ran into the MUL or the div opcode, then you would just instinctively you would have some understanding based on parameter 2 is applied to parameter 1 relative to whatever the opcode is. And so you could just, well, there's a div. I don't know what the hell a div means. Well, yes, you do, because you know what division is in the basic sense. So you just take parameter 2, you divide it into parameter 1, and then that's it. And the value of that, or the value of that operation is stored in parameter 1. There are some, when you get into division and things like that, there are some more crazy things as far as the remainders and whatnot go. But as for the initial sort of premise, the general introduction that we're trying to do here, we're not going to talk about remainders in any sort of substantive way. But we are going to scroll down here just a little bit more. It's possible I'm missing the subs or I'm sorry, the dibs. Can I talk? The moles or the divs? All right, I don't really care enough to hunt it down. So we're going to close that. We're going to close this. We're going to close that. So we have a basic understanding at this point of what a register is. We're going to go over in the next video about some of the more registers with a purpose, and we have a basic mapping sort of conceptually of what the different opcodes do, how they operate on the different parameters that are fed to them, and how those opcodes map to sort of the implicit understanding that we have as human beings relative to the basic arithmetic operations, which would be addition, subtraction, division, and multiplication. And an assignment, because we talked about the move statement. So we will pick this back up in the next video.